Coder, you have reached part 7 in a series of tutorials about Chromia and Rell. My goal is to take Goblin Chess here online. Last episode we saw how to join entities in Rell, and this episode we will test our code in the same manner as in episode 5. To simplify the testing, I will refactor the code by using a Rell function. A function is like a query and operation, but with the difference that it cannot be called from the internet, meaning that there will be no REST API generated for a function. I'm breaking out the logic of consume lobby entry into a function. Note that the function is accepting the type player entity as a parameter type. This is valid, but be careful if you are passing around a collection of entities, since it may result in performance problems. I want another query that accepts the player name instead of the pub key. The reason why I do this is that the name is conceptually easier when doing manual test. To test our code, we need more players. We use the CHR tool with the keygen command to create Pelle, Kalle and Anna. Yes, these are schoolbook Swedish names, perfect for testing. Like in episode 5, we use createPlayer to create the 4 players. Every player must use its own key pair, or this won't work. Yep, they are stored. I want 3 players to be in the lobby, but Kalle wants to play a 10 minutes game while the other play faster. We call our query based on the player name Olle and the game type 10 minutes. And we should find Kalle, who is the only one of that type. Yeah, it seems to be working on a basic level, but now we want to test if players of equal skill are being matched. In episode 5, we learned how to look directly into the tables. After \DT, we see the new lobby table. Data in here is what we expect. Since we're just testing, we can change the data. Note that on the Chromia mainnet we could never update the tables directly. This would cause the altered node to become out of sync with the network. A blockchain runs on a group of identical nodes. If one node makes a change, the other nodes won't know about it initially. Eventually though, your node will misbehave and be kicked out from the group. Also, if a new node is added to the network, it will run all old transactions in the blockchain, slowly building up the database, but it will know nothing about your manual changes, since they do not come from a transaction. In our case, we only have one node, so it doesn't matter what we do. There's nobody else around to check on us. Okay, let's run the same query again. This time we get null, since there's nobody within 200 ELO from Olle. If Olle now looks for a 5-minute game, he will find Pelle, who is the closest in ELO rating. To test your DApp manually this way is simple but crude. A more systematic way is to use automatic testing, which we will look at in the next episode.